like 10 years or 20 years, this is a pain in the butt way to do it.
Yes.
However, this equation can be put into your calculator as, like, let's say in 10 years, here's what you do. You hit 100 times 1.05 caret mark 10. Brian, Rodney, somebody tell me what this is?
I think since you're a math teacher, you should be able to do it mentally.
Dream on, darling. These decimals get ugly.
Wait a minute, my facts have been wrong.
Come on, Brian.
100 times 1.05 caret mark. What'd you get?
162.8.
Point what? 88.
One thing you just put a dot instead of like a blue star.
Because I'm doing the asterisk because I want to show what it looks like on the calculator.
So in 10 years, you make $62. That's awesome.
You can retire. In Zimbabwe, where the inflation rate is insane. Okay, in 50 years.
Oh.
You know how rich we'd be if we moved to like to a third world country?
Oh, hell yeah.
Yeah, then you can't make any money once you're there. So you got to make money here and then like go retire to like Zimbabwe.
That's cool. I'm down.
And live in a huge mansion.
If I can go retire and be like a bazillionaire, why not?
You'll be a bazillionaire in Zimbabwe, but it's like $1 million for a loaf of bread. It's really...
Well, I don't need no stinking bread.
Alright, in 50 years, 100 times 1.05 hatch mark 50 equals.
Wait, I'm gonna do it. Crap. Damn it.
Mimi narrates her own fail.
Wah wah.
I can't do
Wait.
oh.
Wait, Mr. B, hypothetically, couldn't you multiply 162.88 by 5 and get this?
By
5, because then it's 10 to
This is
50.
impossible.
Could you?
no, because it's not going to go up like that. That's linear thinking. That's I'll hold that thought. I'll get to that in a minute. Yes.
1146.739979.
Okay. Whoa. What? Round out to the 2 decimals because these are pennies we're talking about. Go ahead.
1146. Point
She might have $1,000.
or 74.
Okay. Can we get some independent verification of that by any chance?
You don't trust me?
Hell no.
Look it for yourself.
That's all right. Okay. Yeah. So you'll have gone from $100 to $1,000, and it will only have taken you 50 years.
That sucks.
Nice.
Yeah.
Only 50 years?
Only 50 years.
Wow.
All right. Yeah, it's kind of sad. Okay. We'll get into compound interest. I'll show you how this sometimes works a little better. Okay. Yes.
What if you had like 20 different bank accounts with like $5?
Then the IRS would assume you were doing it to hide your fortune and were trying to avoid paying taxes.
So they could make more.
No, you can. 5% is actually a really high savings rate right now. Interest rates are low for both savings and loans. The bad news is you can't get 5% right now on even a bank account to save money. The good news is you can get loans for around 5 or 6%. When some of my friends were first buying houses in the 80s, you could get like 8, 9, 10% on a savings account if you put in enough money. The more money you put in, the higher the interest rate they give you. If you wanted to buy a house, the mortgage loan rates were like 18, 19, 20%. So, yeah, that was kind of rough.
Are we done with that problem?
We're done with that problem, yeah. This is just an example. Pardon?
Did you say we graphed?
No.
We may graph them, but not yet. Now I don't have time to go over every type of problem you'll encounter, or even in the word problems tonight. But the idea is once you figure out a percentage, you keep multiplying by it over and over again. So I'm going to set up another problem for you, and this example is going to be model
An easy one, right?
the depreciation of a $20,000 car which loses 3% of its value.
So now you're
Each
losing it
year.
before you were gaining it?
Yeah, that was gaining it. This is losing it.
So would you subtract it or divide it?
Close. Let me tell you a little about what's happening here. You buy a car. You drive it off the lot. That car has gone down in value.
Why?
A lot, because no one wants it once you've driven it. The dealer's not going to buy it back to you for full price. They've got to make some money off the deal.
That's why used cars are so cheap.
That's why used cars are so cheap. And this is assuming you maintain the car perfectly.
Yeah.
Now there are a few exceptions to this. If you maintain like a British sports car for 50 years, then it's an antique and then it's worth something. But pretty much other than that, I can maintain my Ford Focus for the next 50 years, and it ain't going up in value.
Nope.
That'll never be. I don't think that'll ever be a historical artifact. Now, here's the thing about loses, and I have to do this fairly quickly, unfortunately.
You do know you have a minute left.
No, we've
Well, I've got a couple. Anyway, but this is okay.
Well, we're ahead.
If you're losing 3% of your value, here's how you think about these problems.
Oh,
Depreciate
we
problems.
have to go like right after this class. Can you give us the homework?
Okay, quiet. Anyway, it's online. If you lose 3% of your value of something, how much value are you keeping? 97%. You can always count on Rodney for the calculations.
Yay, Rodney.
Okay, so what happens is this car value,
Is it
when the dealer sells it to you, it's worth $20,000. Okay, and then as the years go by, it only keeps 97% of its value.
So would you subtract by 90 each time?
Nope. What you do is you multiply times 0.97.
Why?
Well, okay, multiplying by 1. If I multiply 20,000 times 1, I get 20,000, right? Mimi? Mimi, if I multiply 20,000 times 1, I get 20,000, right?
Sure.
Okay, so if I multiply 20,000 by less than 1, I get something less than 20,000.
Oh, never mind. I was gonna say, but
So you keep so when you get a depreciation problem, if you're losing money, don't try and worry about the 3%.
oh, never mind.
Figure out what value you're keeping and multiply times that over and over again. So this is the model. The equation is called the model. And then my question is, what is the car worth in 10 years? Now, Eliza's starting to go in a clever direction. That's wrong for this type of problem. This is not what's called a linear problem, like the lines we were graphing before. This doesn't go down by the same amount each year. When you're dealing with percentages, the numbers change every year. Quick way to remember it is if something changes by the same amount every year, that's like slope of a line, and it'll graph a line.
Okay.
If something goes up or down by a different amount every year, it's going to look like one of these exponential curves that we're doing. This is actually would be what's called exponential decay, which we'll talk more about tomorrow. But in this case, what is 20,000 star, Nimi, times 0.97 hatch mark 10? What's the car worth?
14,074.84.
14,000, I'm sorry?
Oh, 74. No, yeah.
074?
No, 74.
748, okay.
And then I said 0.84.
0.84.
But would you round it because it's above 5, so would you round it to 85?
Yes, you would. Yes, you would. Thank you for double checking that. $14,748.85.
85.
85.
New York now?
Apparently so. I was there last weekend and now it's in my soul.
There's no 8.
You have no soul.
Can we have the homework?
Okay, now, the homework tonight is...
It's wrong.
What's wrong?
Numbers.
It's
Rodney, help us out here.
Nimi, you failed.
No.
Okay, can
Right.
someone say the homework?
Please tell us the homework.
This is bothering me now.
Nimi, you did 2,000, not 20,000.
But she still got 14,000 for the answer.
Yeah, but she missed a couple numbers. And it's
So do you know what the number should be, Rodney?
it's all that .48. Nimi, take your calculator.
Paint what? 0.40 what?
48.
0.48, thank you.
Okay,
Okay,
who cares?
$14,748.48. The point is, in the word problems tonight, you're going to have to figure out what you're multiplying again over and over, okay?
Okay.
In this case, to get a depreciation, you're multiplying by 0.97 over and over again. To get an interest rate, you're multiplying by 1.05 over and over again. So tonight, think about it, the word problems.
What's tonight's homework?